10. We are Team Erica, and now we're gonna give you an introduction of our decision tree implementation for task 11. We used Java to implement this decision tree. We chose the algorithm C4.5. Which is, dynamically calculate the split point for continuous data or non-continuous data, and then, just when you're building every tree node, you are calculating the info gain ratio again and choose the maximum one. So that's pretty much the whole idea in the background. Let's take a look at our code. So the first one is file IO. To save the time, I'm just gonna give you some simple introduction. Now we have a string s which represent the file address, and then we take the file, we return a list of map of string. The map represent each column of data, like here, each column of data over here. So and then in the map, it contains the attribute for the string. Its type is student, lifestyle is spent greater than saving, the idea. So we have a list of this which represent this whole data over here, and then we actually can use this data to build our tree. So from here you can see we have the list. That's the train set over here. We have it, and then we actually generate the tree. Use the helper function, and this is the recursive function. So when it stop, the condition that it stop, it's all the data set in all the data in this train set has the same label attributes, has the same result attributes. So and then we simply just return a leaf tree node. And then if the data set is less or equal than 5, then we shouldn't keep splitting tree. We should just simply take a voting and then return a leaf node. So this is how we actually implement our tree. So first we calculate the total entropy over here. That use this function, how to calculate the info, and then this function, the total entropy. So we get the distribution first, and then we calculate use this function over here to calculate the info. The info, it means information contains in this in this attribute. And then we have the total entropy. We have the total entropy, and then for each of the attributes we have to calculate an info gain ratio for each attribute in this data set. But however, how do we do this? If it is continuous, which means real data, then we have to dynamically choose the split point. How do we dynamically choose the split point? Let's take an example. If we over here we take the vacations example, the first three sets, we have 6, 11, and 7. So let's mark us down here, 6, 11, and 7. So we sort this array, which means 6, 7, and 11. Then we can choose the split point first over here, which means we calculate the info gain ratio for only 6 and the 7 and 11, and store the temporary location, and then we split it over here. That we calculate the info gain ratio for 6 and 7 and 11. So we compare those and then find the maximum info gain ratio to represent this attribute, and we put it in this map, the info gain map. So for the non-continuous data, then it's much more easier to calculate the info gain ratio. Just simply divide it into, split it, and then split the whole data set into different split points, which is just those split point. It won't change. And then put the info gain ratio into this info gain map. And we have the info gain ratio for each attribute. Then we chose the maximum one, and then the current node would be the attribute for current node would be, you know, the max will be the attribute contains the maximum info gain ratio. So that's over here. And then we have to calculate the children. And how do we calculate the children? If it's a real type, then we have the split point because we calculated it, and then we compare each data in the data set, in the train set, to compare it with the split point. If it is less than, then we put in this list. If it's not less than, then we put in this list, and then we put both lists into this current node as children of this current node. And then for the non-continuous data, then we have, you know, a bunch of that depends on the data, depends on the attribute. Then we have a bunch of, you know, different split points, and then we just chose the correct category, and then put the whole data set, split the whole data set into different list of maps, and then put all this list to be the children of the current node that is over here. And also, why, maybe you noticed this in this line of code, why will we have a final result for the current node even the node is not a leaf? Because what I have reserved after I wrote the code, when I run the test, it's just sometimes you got a null pointer exception because, you know, some of the node, the tree path in the test data set maybe hasn't been revealed in the train data set. So probably it's the best idea to have a final result for each node, just in case just the, you know, the test data set won't go any further, then it will still have a final result, which is the current node final result. And how do we do this? It's just voting on the current tree set. So we have the tree node, that is the tree node class. We have children, that is a map of string of tree nodes, and then we have a string that is attribute. We have a double is value. We have a final result. We have a boolean that is leaf. So we can stop there if it is a leaf. Okay, see how many